So now we come to the domain 3 proper, which is security, concepts of security architecture and engineering. Okay. There is a lot of things, but you need to understand few things very clearly, and few things you just need to be aware. Okay. Now, before we take on the concept of subject, security architecture and engineering, if you look at security, security is an access problem. Okay. Somebody is trying to access something, either data or information. Okay. And somebody is trying to access it. Security has to ensure that the person who's asking access is the right guy. Okay. And somewhere this concept is called a subject and a object model. Okay. There's always a subject who's trying to access a object, and to ensure security sets the access control in between. So whenever you see systems, you will see a subject is always the active entity and the object is always the passive entity. Active entity always is trying to access the passive entity, which is the object. Okay. Now once you develop system architectures, okay, if you look at the development of system architecture, it happened in two ways. One is in the open architectures, and other is the closed architectures. Okay. Now, who do you trust more? Do you trust an open architecture or a closed architecture? If you look at Linux systems, right? If you look at Linux, okay, systems, these are all open architecture. But if you look at Windows or Mac, okay, though they are based on IBM, Windows is based on IBM, XT format. Mac is ultimately based, kernel-wise, it is based on Unix, right? But they're closed architectures. You do not come to know how they implement. Whereas Linux, the entire source code is available to you. And that's why you have architectures which are open sourced and closed sourced. Okay. At times, closed architecture could be, better secured because a lot of business is riding on that, right? So you might have systems which are better supported, better used, whereas open systems may be discarded. Okay, people may not maintain open architecture systems for a very long amount of time. Okay, so that is the concept of open and closed systems. The first thing we understood was subject and object. Second is we saw, okay, closed versus open systems. Okay. Third thing we know is whenever you're designing security, you should have secure defaults. That means any system which you are designing from start, you should try to design it in a secure manner. Certain amount of default security should be inbuilt into the system once you are architecting and engineering that system. Okay. Whenever you're designing systems, you ensure that if the systems are failing, if the systems go into failing, they should not become unsecure. Okay, they should fail into a secure configuration. Okay, so whenever you're designing information systems and you anticipate that there is going to be some kind of a failure, please do not, it should not happen that in the first pretext your system becomes highly insecure. Even it is failing, it should fail in a manner that there is a degradation of services in such a manner that it is secure, and it should not just fail and become a open system. Okay, so for failing, there are many concepts. There is fail secure. Systems might be designed to fail secure. Systems might be designed to fail open. Okay, systems might be designed to fail close. Okay, systems might be designed to fail into a safe mode. When you design a system to fail open, you are trying to protect human lives. Right? You go to a movie hall, if there is a fire, the doors will open. You're trying to protect people. Okay. Okay. It is when it is fail safe, you're trying to if systems are failing into a safe mode. Okay, then you are trying to protect confidentiality and integrity. Right? You don't want the information to go wherever, but if it is fail safe, some point in time you are also trying to protect people. Okay, say you are in a room which is not affected by fire and the door closes because it senses that the people are there, it needs to close the door. The system controls might. So you have to evaluate the situation. Are you trying to protect life? If you're trying to protect life, whether you should close the control or you should open the control. But when it is information is generally, whether it is fail safe or fail closed or fail secure, you're trying to protect the information's confidentiality and integrity. But fail open generally protects the availability. Okay, fail open systems generally try to protect the availability of systems, and fail open concepts are applied generally in OT systems. Okay, where availability is much more important than protecting the confidentiality and integrity, because OT systems are designed to manufacture, designed to produce some things. Okay, whenever you're designing security, keep it simple. Do not make uh, security as a very complex thing. Keep it as simple as possible. A philosophy called keep it simple and straight. Okay, keep it simple and straight. Okay. Then there is a concept of zero trust. Okay, it is easier said than done. That zero trust. Zero trust means any subject which is trying to access an object. Okay, the object should not naturally trust the subject. There has to be a verification. Somebody should always verify whether the subject is allowed to access the object. This is as simple way in which you can explain zero trust to anyone. Whenever there is a requirement of a subject trying to access the object, you ensure that there is someone to verify it. If there is someone, then you have approached, then your approach is of zero trust. You naturally do not give access, you naturally do not establish trust. Okay. Now imagine every time you are trying to access a resource, a subject is trying to access a resource, you have a access control. Okay, that means you will have multiple segmentations in your network. Say if you this is your switch and you're connected to the switch, and then this is connected to another switch which is connected to a server. Now to access this network you will have access control mechanism. To access the servers you might have access control. That means you are naturally creating segments in your network. Zero trust leads to micro segmentation. Micro-segmentation, you have to deploy certain devices which can segment your network, segment your applications. Okay, so such approach is called micro-segmentation, and the devices which are used to achieve micro-segmentation are called inter-segmentation firewalls. Inter-segmentation, wherein you deploying firewalls to create a segment within a trusted networks. Okay, such segmentation is called zero trust networking. Okay. Then whenever you are designing systems, if your systems are going to handle PII or PHI or proprietary data, you need to design the systems with the factor of privacy by design. Okay. That means when you're designing the system which are going to handle privacy data, you ensure that your systems are designed in such a manner that privacy aspects are incorporated in the system. Okay, such philosophy is taken from a concept called PBD, Privacy by Design Framework. Okay, so if you refer to the PBD framework, you can incorporate privacy aspects into your application building, into your system building right from the start, right from the design stage. and you're not doing a patchwork once your system is ready. So these are the concepts, right? Whenever you are designing systems, ensure that even if you are creating the trust between a subject and an object, even if you don't have zero trust, but you're creating a trust, still verify this trust always. Because if you're not verifying, then there will be inherent trust, and inherent trust is not good once you are considering security aspects. Okay, understood? Any doubts till now in these concepts? Okay, so what do we discussed? We discussed the secure design principles. We discussed subjects and objects, open system, secure defaults, fail secure, keep trust, right, trust but verify. Shared responsibility is something which Ismail asked a question. What is shared responsibility? And separation of duties, I had already discussed that any key task should be, separated between two subjects and should not be executed by one subject. So there should be separation of duties. Okay, any doubts till now? Sure, no doubts. Okay, so now let's see that once system, you are trying to secure a system, who creates the system, right? Systems are either created by, hardware manufacturers or software developers, right? System is a combination of hardware plus software. Okay. Now, hardware once designed, maximum times the software is what rides on the hardware to, create secure function. Okay, now the techniques which software developers use for, I'll say, ensuring confidentiality, integrity, and availability of the data which is riding on those systems. Okay, the developers use certain kind of techniques. Okay, and the first technique is called a confinement. Now, what is confinement? Confinement is typical to what is called sandboxing. Okay, now suppose there is a process which is running inside a CPU. Okay, this is a process which is running inside a CPU, and it is trying to fetch some data from the memory, right? And this memory is having some PII data, right? Software developers will ensure that this particular process is carried out in a sandboxed manner. No other process is able to interfere. Okay, such kind of programming is done by using confinement measures. Confinement basically relates to, on the memory chip, there is a certain block of memory which is dedicated to this particular process. It's called confinement. Okay, then there is something called bounds. When developers are developing, this softwares for the systems, critical, say there are multiple programs which are running on systems, right? Program A, B, C, D. You do not want B to interfere with C or A to interfere with B. So what happens is, the CPU space is shared by program A in a manner, in such a way that firstly it is written on the memory space, okay, within certain regions. So memory space 0 to 3 is allocated to program A. It is bounded to certain location, and program B will be in another location. Okay, so such bounds are created at memory level, at CPU level, so that systems have no interference with any other system, right? These are called bounds between the upper limit and the lower limit between which you can function. The third concept is called isolation. Somewhere isolation and confinement are similar process, okay? But when you ensure that a process executes between given bounds, okay? This was the memory space allocated, right? 0 to 3. So if you are ensuring this process executes in only these confined spaces, it's called being isolated. It is being executed in an isolated manner. Now, these are generally done so that there is no interference between different processes. Okay, so you should know what is confinement, what is isolation, and what is bounds. Okay, now whenever a subject, we discuss subject and object. Now, all information systems revolve around subject and object, right? So now, whenever you know a subject is trying to access object has to trust. There has to be creation of trust. Who creates the trust? The access control mechanism. Okay, and this access control mechanism is based on certain fundamental models. And now we will see what are the fundamental models which drive these access control policies. Okay, clear till now? Any doubts? There are a lot of models, but we will discuss one by one each concept. Okay, the first is something called a trusted computing base. Very important, gentlemen. This forms part of any secure system. Okay, now what a trusted computing base means, say this is a system. Okay, and this is the core of the system. Okay, this is the core of the system, and for the system to work perfectly, okay, the system to work perfectly, this particular system cannot be interfered with. The system has to maintain the the system should maintain the integrity and confidentiality and availability. So all the designs which is supposed to meet, this cannot be violated. Okay, that means anyone who's coming to the system knows that they can trust this system. Okay, that means this is that core of the system where you impart all your security policies to make the system as security functional as possible. Okay, now if you look at your operating system, what is the most important part where you employ your all the security policies? Mainly the OS kernel. Yeah. OS kernel is where it is a trusted computing base. It is controlling all aspects of. You may not trust applications, you may not trust drivers, you may not trust devices, but kernel is the trusted computing base because it controls it. This is where you apply all the security elements. Okay. Now TCB generally is protected by a security perimeter. It's called a security perimeter. Okay, and only trusted functions can only will be allowed to interact with the TCB. Okay, now TCB controls the concerned security issues of that system, and to monitor the security aspects of the system, there is a component called reference monitor. Okay, so you have a complete system inside which sits your TCB, trusted computing base, and you have a security perimeter, right? And somebody monitors this exchange with the TCP in the non-trusted. This is the non-trusted environment. These are not security focused environment, right? And this is where the entire security focused environment is there. So from non-trusted to trusted, there is someone who is doing the gatekeeping. That gatekeeping architecture is called a reference monitor. He is checking that who's trying to access the trusted computing base of the systems. And such reference monitors are actually nothing but actually they sit between the trust and the non-trusted entity. Okay. Now, this is a very important concept, gentlemen, and you must remember this. At times, the reference monitor is also called a security kernel. A security kernel, that is the base of the security. It is because a reference monitor is actually nothing but the access control between the TCB and the non-trusted system, non-trusted part of the system. Okay. So reference monitor is basically access. So TCP becomes the object and rest everyone becomes the subject. And since reference monitor is controlling the access to the TCB, it becomes the access control mechanism or security kernel. Okay. Okay. Any doubts? Please ask. Now, if there is no doubts, I'll go ahead. Now, once you look at subject trying to access an object, okay, you can interpret this function as a state machine or as an information flow. Okay. Now, if you look at the flow is from, if you remember how electrons travel, you will understand what is flow. The information flows from object to subject, whereas the state of this particular system flows from subject to object. Right? The state, if you look at the state, the subject is moving to access the object. And if you look at the flow, you can interpret that the information is flowing from the object to the subject. If you are assessing a system based on the state of the subject and the state of the object, that assessment is called a state machine model. If you are assessing the flow of the information from place A to place B, such analysis is called a information flow model. Clear? Any doubts? What is state machine and what is information flow, right? So whenever you're analyzing, it will be called a state machine model or a information flow model. There is something called non-interference model. When subject is accessing an object, okay, this is doing it is in its own domain. Okay, this is subject 1 accessing some object and subject 2 accessing another object 2, and they both are mutually exclusive. That means I am doing my job, you are doing your job, we both are not concerned with each other. Such kind of modeling is called a non-interference model. Okay, you employ what happens is the non-information interference model leads to what? If you see, if subject 2 reads this data and passes this information somewhere, you will not come to know. So basically, non-interference model leads to something called creation of a covert channel. Okay, if you look at what you are doing, I am not concerned with you, then you are creating a covert channel. I'm not looking at you what you are doing. So this might be a bad process this might be a hacker who is trying to access a reputed data, but you are not bothered. So this might create something called a covert channel. What is a covert channel? A covert channel is a channel which looks authenticated, but it is exfiltrating information, right? Non-interference model is applied to, when you are looking at Trojan horses, backdoors. Okay. So what happens? Application developer created a small channel which is not visible to anyone. It is parallel to actual processes. Looks very, very, genuine, but actually it is a non-interference channel which is exfiltrating data out from the system. Such models are called non-interference model. Then next is the take grant model. Take grant model are relay models. They are relay models. Say subject A is trying to access object B. Okay, but object B doesn't trust A, but But subject A is trusted by subject C, which is trusted by object B. Now, since object B knows that subject C is trusted by subject A, subject C trusts subject A, object B will give access to the subject. Okay, so this is the take grant model. Object B says, okay, fine. If you trust him, then I'll give you the access. Such such accesses happen when you say there is a file system. Okay, there is a file. Okay, and subject A is trying to access file. Okay, but file system sees that subject A is trusted by subject B. So what happens is file says, okay, fine, you can take access, you can take the rights. So what subject A does is it takes its rights from subject B. Subject B had rights, it takes that rights to execute actions on the file. There could be many more. There could be many such actions. It could be take access, grant access. Okay, right. So these are called the take and grant model. So you have to create rules between subject A and subject B for the object to be accessed. Okay. Now, please understand these. Where does these models apply? These models actually apply between the subject and the object. So basically, you're applying these models on the access control logic, whether hardware or software. Okay. Then the next model is called the access control matrix. You have, lot of subjects 1, 2, 3, 4, 5, 6, and you have lot of objects. Okay, and you have what are the rights? You have the read rights, write rights. So you basically create a model. What is it? This is nothing but an access control list, right? This is how generally firewalls are programmed. So access control matrix are a list of permissions which you give to a particular subject, right? Source, destination, allow, deny, right? You create a small model, right? This is called the access control matrix.
Thank you for watching. Don't forget to subscribe our channel.